Okay, here we are. We're in Unit 4 still, and we've got one more topic, and that topic is scientific notation. But today, we are going to do some calculations with numbers that are written in scientific notation. So, once we do this, we'll be really solid on scientific notation, and we'll be done with Unit 4. Let's go ahead and cut right to the chase. The problems you're going to do today are going to be problems like this. You're going to have a nice scientific notation-y looking number like that. And then you're going to take that and you're going to add another number that's written in scientific notation. Or we might do subtraction or multiplication or division as well. But for now, we've got an addition problem. And in order to add these together, here's what we're basically going to do. We're going to take both of these numbers out of scientific notation, put them into regular old standard notation, then add them together, and then put them back into scientific notation at the end. So let's take the green number, 6.11 times 10 to the 6th power. You've got to move that decimal place 6 times. So it should be 6,110,000. And if you want to pause it for a second, you can count the spots that we moved it, and there are 6 of them. So that's why that number turned into that number. Okay, the blue number, 1.24 times 10 to the 4th power. We're going to move that decimal 4 spots. So it's going to be, instead of 1.24, it's going to be 12400, which is 12,400. Now that you have them in regular notation, you can just add them up. Okay? Make sure you line up the numbers correctly, because that's how we do addition, right? And then just add them column by column. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 4 is 4. 0 plus 2 is 2. There's a 1 plus 1, which is 2, and then that one doesn't get anything added to it, and neither does that 6. And we'll put those commas in for good measure. And now we have our answer. Our answer is 6,122,400, but we're going to make sure we put our answer back into scientific notation. So how did I get 6.1224 times 10 to the 6th? Well, I counted these 1, 2, 3, 4, 5, 6, and I made it 6.1224 times 10 to the 6th power. And that's all you got to do. You just unscientific notationize those two numbers, and then do the addition or subtraction or whatever you need to do, and then re-scientific notationize your answer so that your answer is in scientific notation. All right, try this one. And then try this one. Yeah, that's a subtraction problem. I think you can handle it. Okay, you can also do multiplication problems as well, but this time, when we have two numbers and they're both written in scientific notation and we're going to times them together, we're not going to take them out of scientific notation. Here's what we're going to do. We're going to take the two decimally parts in the front and we're going to multiply those together. And then we're going to take the 10 parts in the back and we're going to multiply those together. So the front parts, 3.4 times 2.9, you can just do that on a calculator and you're going to get 9.86. Try it if you want to, or just trust me. It comes out to 9.86. The 10 to the 6th times 10 to the 3rd power is going to come out to 10 to the 9th power. And if you don't remember why, when in doubt, write it out. 10, 10, 10, 10, 10, 10 times 10, 10, 10. And if you count up all those 10s, you've got 9 of them. And basically, we have our answer in scientific notation right now. It's 9.86 times 10 to the 9th power. Just make sure that the answer that you get is really officially in scientific notation. It's got to only have one digit in front of the decimal. We do have that, and so we are good to go. Warning though, if you are doing a problem and you get an answer like this, where it's 27.4 times 10 to the 10th power, and you see that there's 2 digits in front of the decimal, and you know it's not supposed to be like that, and we want the decimal to be between the 2 and the 7 instead of the 7 and the 4, okay, we're going to have to make sure our answer has only one digit in the front. So we're going to take the 27.4 and we're going to make it 2.74 by moving that decimal to the left. Notice though that when we make it 2.74, we had to change the exponent on the 10 And we did that because we moved the decimal to the left once, so we had to add 1 to our exponent. You can try a when in doubt, write it out on this one if you need to, or again, you can just trust me. When you move the decimal to the left once, you got to add 1. If you were to move it to the right once, you would have to subtract 1. Okay, try a multiplication problem. Here you go. And of course, you can also do division, so I'll just give you one example of that. Same problem as before, but I turned it into a division problem this time. We're going to do the same thing though. We're going to divide the front two numbers, and then we're going to divide the back two 10 numbers. You can just use a calculator for the front part. 3.4 divided by 2.9 comes out to about 1.17. I rounded that up, but we'll just leave it that way. Now, 10 to the 6th power divided by 10 cubed is going to be 10 cubed. Remember, that's because 10 to the 6th divided by 10 cubed is kind of like 10 to the 6th over 10 cubed. And in that situation, don't you do 10 to the 6 minus 3? Don't you do the 6 minus the 3? Oh yeah, that gives us 10 cubed. That's where I got that answer. And hey, look, we're done because we have a nice scientific notation-y looking answer, and we are finished. That's basically it for today. I want you to try one more problem. It's a division one. So give it a whirl, see what you come up with, and we will check our answers together tomorrow.